All right, welcome back. So for problem type 3, I'm pretty sure I'm going to do 2 examples because this is when we're dealing with those, inverse trig functions. And I know it gets a little complicated because there's a bunch of steps involved. So let's get started. So we're going to rewrite sine of 2 inverse tangent of u as an algebraic expression in u, keeping things in variables. So let me get my pen ready. Just like we've been doing with these inverse functions, we're going to make a substitution. I'm going to pick theta. You can pick another letter if you want, whatever works for you. You can pick x. Let theta equal this inverse tangent. Theta equals inverse tangent of u. Now I'm going to go ahead and rewrite this. Remember, inverse tangent can be rewritten as tangent of this angle theta is going to be equal to u. And I'm going to go ahead and put that u over 1, right? Because we're going to, build a triangle, look what x is, look what y and r are, and go from there. Before we do all that, let's just go ahead and rewrite this problem. So we have sine of 2 inverse tangent u, but we substituted in, right? So now we have sine of 2 theta, because we said theta is equal to this inverse tangent of u. Well, double angle formula. We know this one. So this is equal to 2 sine theta cosine theta. And we want to simplify this, again, in terms of u, and there's no u's here. So we're going to have to figure out what sine of theta is and cosine of theta is, and that's when we come back over here and work with this triangle. I'm going to change up the color a little bit. So tangent, we know, is y over x, okay? So we have x is equal to 1, and again, that's why I put this u over 1, right? Tangent is equal to y over x. So y has a value and x has a value, and any whole number or just variable that's by itself and not in a fraction always can put it over 1. So x is equal to 1, y is equal to u, and then we don't know what r is. That's what we're going to figure out. So you can go straight to plugging into the formula. If you would like to build a triangle, you can. I'll go ahead and just do that. So when we're working with these variable expressions, if you recall, we can just stick with the first quadrant. So the inverse trig functions, remember, they all live in a special areas. The sine and tangent trig functions live in quadrants either 1 or 4. We're going to pick 1 because everything's positive. The inverse cosine lives in quadrants 1 or 2. But again, we usually always just pick quadrant 1 because it makes life a lot easier. And just to reiterate, this is only because we're working with these variables that we don't know exactly what the values are. If they're giving us, exact values, like, tangent of whatever equals negative 2/3, I think we had an example like that before, you can figure out what your x is, your y is, and your r are, and you can figure out where that triangle is going to live. But when we're working with these variables, we can't. So we're just going to put everything into this first quadrant. So I'm going to have some angle, theta. My x is 1, so this is my 1. I guess I should finish this triangle in the same color before I start adding new colors. My y is u, and we don't know what the r is. So let's solve. Pythagorean theorem. 1 squared, which is just 1, plus u squared is equal to r squared, because we don't know what r is. And that's what we're solving for. We need to solve for r. So all we have to do is square root both sides. Now remember, when we take the square root of both sides, we're going to get that plus or minus out front. Plus or minus the square root of 1 plus u squared. But we're working with r. R is always positive, so we're going to keep just the positive version. Okay, so real quick, I tend to use the X and the Y and the R, right? But if you build your triangle and you're more comfortable with the SOHCAHTOA, you get the same values, okay? So here, I'll show you, because we actually need to figure out sine and cosine, right? That's what we need to finish this problem. So let me pick another color. All right, let's start with sine. All right, well, sine is equal to sine of theta, sine of our angle, is equal to y over r, right? Our y value happens to be this u, and then it's going to be over r. So just notice, sine, if we use, this triangle form, SOHCAHTOA, sine is equal to the opposite over hypotenuse. Our opposite is u, our hypotenuse is r. So y over r and O over h, it's the same thing. You get the same exact value. So however you want to approach it, you do what works best for you. So our y was u, our r was this lovely thing, the square root of 1 plus u squared. Let me scroll down just a little bit. And we also need cosine. Same idea, we can use x over r, or if you're comfortable with the triangle sides, same thing as a over h. You're going to get the same values no matter what, as long as you set up your triangle properly. So our x was 1, and our r is the square root of 1 plus u squared. Okay, so now we're going to come back to this problem. The whole point of doing all this was so we can figure out what sine of theta is and what cosine of theta is, because we don't know what they are at this moment. All we knew was tangent of theta equaled u. So we had to kind of go through all this work to be able to figure out these two pieces. So, and this part's not too bad, because we just plug and chug. So we have 2 times, my sine was u over square root of 1 plus u squared. And then our cosine was 1 over square root of 1 plus u squared. All right, and this is going to work out nicely. So remember, this 2 is technically a 2 over 1. So that's going to be multiplied across the top. We have 2 times u times 1. That's just 2u. All over the square root of 1 plus u squared times the square root of 1 plus u squared is 1 plus u squared, right? The square roots are going to cancel. And then we're done. Leave your answer like that. No need to, you could do some more algebra, but it's just going to make it a little bit more complicated. So everything is in terms of u. That is your final answer. All right, so since this is such a lengthy process for these problems, I am going to be posting another example. See you then.